It's time to chill out and get ready for a mediocre Q&A live stream. If you're old enough, grab yourself your favorite adult beverage, and if you're not, stick with apple juice. Put your feet up and relax. If you have any questions, feel free to ask them in the chat. And now let's cue up the intro music. Yeah, I think Nightbot jumped the gun there. Bill, Curious HVAC guy, he kind of put the movie quotes in there a little too soon. I usually like to do those a little later in the stream, but Bill got it right. But as it scrolls back through, let's see if anybody else can guess it too. So hopefully you guys are doing well. A little bit slow here, cooling off. We've got some cooler evenings. So, and, you know, still kind of warm during the day. I think today it might have been 75, 80-ish or something like that. And then on Friday, I think it was 90, you know, so we just kind of go back and forth. This is our fall weather here where we have cool nights and warm afternoons. So, but hopefully everybody is doing great. Let me see what else. Yeah, Curious HVAC guy, you definitely beat the system there, bud. Mitch Holder, hey man, I'm glad you're here, bud. Thanks to everybody that came to the stream. Hopefully I can hold up to your expectations of what you expect this stream to be. You guys, I just want to start off with a little introduction because we have a lot of new people showing up, coming into the videos and stuff. So just real quick, okay, my name is Chris. I'm a HVAC service technician here in Southern California, small business owner, a partner in a business, I should say. I'm part owner, but I make these videos, originally started making these videos that I make on YouTube and doing these live streams for my employees, and then decided to make them public and then just share the little bit of knowledge that I have, okay? I want to be right up front with you guys. I do not know everything, nor will I ever claim to know everything, okay? A lot of the stuff that I share in my videos is mistakes that I've learned from, okay? And I like to give warning and advice in hopes that I can prevent other people from making the same mistakes, because I've sure made a heck of a lot of mistakes over my small career. So, you know, I release typically 2 videos a week, although last week I didn't release a video on Friday, but I typically release the videos, Friday and Monday is usually my go-to days. So I like to get 2 in a week, and then I do these live streams to kind of recap everything, okay? So for those of you that already know this, get it, but there's some new people in here, so. So I typically like to show the work that I do. I work in restaurant refrigeration as 99% of my work. I do HVAC refrigeration. I don't do any hot side work, but I do, gas-fired heaters and stuff like that, okay? I do not have any more knowledge than any of you guys can have. The only thing that I do is I just like to read stuff. I'm a very curious person, okay? When I don't understand how something works, I dig into it, okay? I got a bunch of comments off of my latest video. My latest video was a walk-in cooler that was not working in the morning, but then in the afternoon it would work fine, okay? And that was kind of a misleading title. I was kind of trying to grab people's attention with that because that is a very common service call that we get in this fall season that we have here in Southern California, okay? We have mild winters here, which leads to a little interesting thing, and I'm going to discuss. That's going to kind of lead me into some other stuff too, and I'll talk about it in a minute. But we have mild winters, and we will have cold evenings, but then we still get warm during the day, and that leads to all kinds of interesting problems. Okay, we do use head pressure controls, and in my situation, for my latest video, we had a head pressure control that was bypassing like it was supposed to. It was doing its job. There's nothing wrong with the head pressure control. Okay, head pressure control valve, I should say. All right, but what was happening was there wasn't enough refrigerant left in the system for the system to operate properly with the head pressure control valve, okay? So the purpose of the head pressure control valve, and I know I'm going to cover some stuff I've already covered, but it needs it because a lot of these are totally misdiagnosed valves and misunderstood valves, okay? So the head pressure control valve is just one of the many means of ways to control the head pressure or the condensing temperature in order to help the expansion valve work properly, okay? So our expansion valve, typically thermostatically controlled expansion valves, we still need a head pressure control on a electronic valve, but thermostatic expansion valves really require that head pressure control when we get low ambience, okay? And guys in the chat, I will address it. I'm not paying attention to it now, but I'll definitely get to your guys' stuff, okay? So I'm just going to keep going on my little tangent right now. So the head pressure control valve is there to help to maintain a pressure differential across our expansion valve. Now, I have an expansion valve. This is a thermostatic expansion valve right here that I did a cutaway on, okay? So what happens here, liquid refrigerant comes in, and it's metered through the orifice in the expansion valve, and then it comes out the other side, okay? We need this expansion valve to meter that refrigerant at a certain flow rate, essentially. Let's call it that, okay? And in order to do that, it has to have a certain pressure differential. So you have to have so much pressure pushing on one side of the valve so that way it can, push the refrigerant through the valve and meter it, okay? Change the state of the refrigerant from a liquid to a mixed vapor, essentially. And we do have electronic expansion valves also. This is not, I do not have a cutaway of an electronic expansion valve, but this is an example of an electronic expansion valve. Now, the head pressure control valve is one of many means of head pressure control. And again, like I said, it's there to maintain a pressure differential. So when it gets really cold outside, our condensing temperature drops, okay? When our condensing temperature drops, the driving force of the refrigerant is not quite there anymore, okay? You need that really high pressure, that somewhat high pressure in the system to push that refrigerant through that valve, okay? And the lower that driving force gets, the harder it is to push the refrigerant at the proper flow rate through that expansion valve. That's our pressure differential. So the head pressure control valve essentially simulates a blocked off condenser or a smaller condenser, okay? So what it does is it backs refrigerant up into the condenser, kind of like if you would block the condenser off with cardboard, okay? And it drives the head pressure up, kind of like if you had a dirty condenser, all right? But it's not as easy as just blocking the condenser off. This valve actuates as the pressure in the system raises and lowers. So when the pressure raises, the valve will throttle down, and then when it lowers, it'll close and start bypassing it. It goes back and forth, okay? So it's not just like a on-off. It'll actually kind of regulate. It's a very small regulation there, but it will move, okay? Or modulate, I should say, is a better word. Now, they're often misunderstood because a lot of people tend to think, oh, the head pressure control valve is failing. That's what's causing the system not to work in the wintertime. That's not necessarily true. Now, in some cases, the valve can fail, all right? And I'll get into that too, but oftentimes the system is low on refrigerant. Now, in order for the system to work properly, there has to be an extra amount of refrigerant added that sits in the system. It sits in the liquid line receiver all summer long, just sitting there, not even being used, okay? And it's called our winter charge. That winter charge needs to be there for that valve to work properly, because when the valve goes to bypass, what it does is it shuts off the flow coming out of the condenser, okay, and then it takes discharge gas, the high temperature superheated vapor coming out of the compressor, and dumps it right into the top of the receiver. But here's the problem. We need 100% liquid refrigerant coming out of the expansion valve, or going to the expansion valve, for the expansion valve to work properly. And if we don't have that liquid refrigerant going to the expansion valve, it's not going to feed refrigerant properly, okay? And then the whole system's going to fall off the map and stop working. So what happens is we have that extra winter charge, that calculated amount of refrigerant always sitting in that receiver. And when that high temperature, high pressure vapor dumps on top of the receiver, it pushes the liquid to the expansion valve, okay? So there's still that liquid seal of refrigerant. They call it a liquid seal because picture, it's just in the bottom of the receiver, there's just liquid sitting in there waiting, okay? So when we push that liquid down, the expansion valve continues to work properly, the system operates. But when that liquid, that winter charge is not there because of a refrigerant leak, then we have issues with the system, okay? In my situation, the pressures were so low that it was causing the system to short cycle, turn on and off, and my box temp was about 55 degrees. Now, it only took about 4 pounds of gas. Actually, it initially took 2 pounds of gas to clear the sight glass, okay? Now, that system holds about 18 pounds of gas is my estimation, okay? Because the winter charge on the system was 14 pounds. So, but that system only took about 2 pounds of gas to clear the sight glass, okay? Another misconception that a lot of people argue with, but this is truth, okay? And this is how this works, is you need a solid column of liquid going to your expansion valve. The sight glass, if it's installed correctly and there's no restrictions before or after it, the sight glass needs to be clear for the expansion valve to work properly, okay? I know that's an argument. I know a lot of people don't agree with that, but that is the truth. If you read any Sporlan documentation, it says that their expansion valves need a solid column of liquid going to their expansion valves, period, okay? Not a liquid vapor mixture. It's a solid column of liquid. Now, I kind of just covered that a little bit. Hopefully that explains some things. I've talked about head pressure control valves many times. The simplest head pressure control valve to understand is the LAC valve. Okay, this is Sporlan's LAC valve. This is a 3-way valve essentially. Okay, there's three ports on it, and basically one port, when the system is not bypassing, the refrigerant does not flow, and that's the discharge port. Okay, so they actually have, now unfortunately on the side that I cut away, this is a valve that's not cut. You guys can't see it, but stamped in the valve body is letters. So C for condenser, this is the line that goes to the condenser. D for discharge, this goes to the discharge of the compressor. And R for receiver, okay? So when this valve is not bypassing, the discharge is going to nowhere, all right? And the refrigerant flow, when it's not bypassing, is coming out or into the C from the condenser and going directly into the receiver. That's the normal operation. So hopefully that answers your guys' questions or kind of clarifies some things. I'm going to talk a little bit more about it too, but I want to get to some questions and comments in the chat, and then I'll get back into the head pressure control valve stuff. So let's see what we got in here. What am I missing here? I know, Primetime, you hate headmaster valves. All right. Let's see. I'm going to start down at the bottom. So if you guys posted something that I didn't get to, definitely repost it again. Okay. So Joe, you asked, what was my receiver level after the winter charge? Okay. The receiver level was just under half, right at about half. And the way that I obtained the receiver level was when I was all done charging the system, I pumped the system down, then took a heat producing device that did not exceed the high temperature limit of the receiver or the soft plug on the receiver, and I went up and down. I passed it up and down the receiver, and then I took my fingers very carefully and went from the bottom of the receiver up until it got to the hot point, okay? What I was doing was, where it's not hot is the liquid refrigerant, and then all of a sudden when the receiver gets really hot, that's the vapor refrigerant. So that's how you know where your liquid level is in the receiver. Be very careful. I'm not going to tell you what kind of heat producing device to use because you can definitely cause some damage and hurt yourselves. Be very, very careful with that, okay? All right, let's see what else we got going on. Does the rule of thumb actually work? Brian Guzman, I don't know what you mean by the rule of thumb. Oh, you have heard it does, but at the same time it doesn't. I don't know what you mean by that, Brian Guzman. Clarify what you mean by rules of thumb, okay? Let's see. What are the ideal evap saturation temps and superheat settings for walk-in coolers and freezers? So ideally, again, this can all be changed by an engineer if you have funky stuff going on, but a general product walk-in cooler is going to have about a 10-degree evaporator TD. Okay, so your evaporator temperature is typically going to be 10 degrees below the air temperature. Now, you need to be very careful when we're talking about evaporator temperatures, because now that we have these really high glide refrigerants, such as 448A, there's a lot more that goes into it, and you need to understand how the glide works. So, but we're going to use the really easy ones, and that's R22. So for R22, my typical evaporator temperature is going to be about 10 degrees below the box temperature, okay? Typical box temperature on a normal walk-in cooler is about 35 degrees, okay? Again, there could be other different situations, okay? But typical general product, okay? Walk-in freezer, you're typically going to have about the same evaporator TD, about 10 degrees. The superheat settings, depending on what type of evaporator coil you have, are going to change, or what kind of metering device you have, okay? With a TXV or thermostatic expansion valve like this on a walk-in cooler, you're typically going to see anywhere from about 10 to 12 degrees evaporator superheat, but it may go a little bit lower. It just depends on what kind of compressor protection you have, okay? On a walk-in freezer, you're typically going to see somewhere between 6 and 8 degrees of superheat, evaporator superheat, okay? But again, everything can change depending on what the customer keeps in their box, what kind of humidity levels they want. Your TD can go up or down, all kinds of stuff, okay? Let's see what else we got. That does not have a sensing bulb. Can the switch be mounted anywhere inside the evaporator cabinet? What do you mean by Kyle Carmen? I don't know what you mean by that, but I don't know if I'm walking into what does not have a switch. Give me some clarification on what you're asking me there, bud. Okay, so Michael Ryan, great question, and I am going to get into that right now. Okay, so any reason why headmaster or head pressure control valve used over a fan control for head pressure control? So it really depends on the situation. Now, this comes down to personal preference. So I live in a very mild climate, and what I mean by that is we typically don't get extremely cold. So what happens when I install a fan cycle switch, especially if I have a condensing unit that has a single condenser fan motor? When I install a fan cycle switch, we have short cycling of the condenser fan motor, okay? And the reason why we do is because we have mild temperatures here. So my average temperature during the day is 55 to 60 degrees. So when we shut off a fan cycle control, the condenser fan motor is going to shut off, then the head pressure is going to be driven up pretty quick, and it's going to happen. And what happens is it's kind of violent on the system. If you ever put a set of gauges on a system, when the fan cycle control is turning on and off like that, you'll start to notice that every time the fan cycle control turns off, the liquid drains out of the sight glass. And then as the head pressure builds up, the liquid builds back up. And then it's just like a vicious cycle. And you start to notice that the box doesn't perform as well because that liquid is kind of, the state change inside the condenser is kind of fluctuating here and there. Now, as you get to bigger condensers and you have more condenser fan motors, you can stage the condenser fan motors. Then fan cycling does pretty much okay, all right? But when you have a single condenser fan motor, I personally don't like using fan cycle switches because I notice that it's a really violent and it kind of affects the operation of the system. That's not to say that fan cycle switches don't work. I mean, they work fine. It's just what you're trying to control, okay? Different situations. Now, if you're using a lot of hot gas defrost, you need that head pressure to be consistent and you don't want it turning on and off a lot or fluctuating. Again, mild climates here in Southern California, so fan cycle switches can tend to be a problem. But I have plenty of systems out there that have fan cycle switches and they have for 20 years and they work fine. Just a personal preference. Head pressure control valves, in my opinion, work fine, but that's just my preference, okay? I will go out on a limb and I will say that majority of the problems with head pressure control valves are improper installation or improper refrigeration practices. One of the most common ways that a head pressure control valve fails is when it gets stuck open, all right? So you go out there in the summertime and you diagnose a bad head pressure control valve because it's leaking by or discharge gas is, causing the head pressure in the system to go up. It's leaking through. A lot of times that's because something's stuck inside the valve. I mean, if you look at the inside of an LAC valve, there's really nothing to it. There's a spring, a rod, and a seat, and that's it. But there's a very, very small area for the refrigerant to flow through. Any kind of contaminants can clog up that valve and cause some problems. Now, you can also lose the dome charge. It works similar to an expansion valve. It has a power head essentially on it that pushes down and opens and closes the valve. So those can fail too. This is not a field replaceable part. They do not sell those at supply houses. At least I've never seen them before. So you usually have to change the whole valve if that situation happens. Now, there's a few more mechanical functions inside some of the other head pressure control valves. This is an OROA valve, I believe, I believe that's what this is called. And these have a few more mechanical parts inside, but they still work with the same concept. It's just a valve that has 3 ways. I don't have a cutaway of this because it's much harder to cut apart. At one point in time, I had Sporlan send me cutaways, but it was just on a temporary. They loaned them to me so I could take some pictures and show them in a stream. I do have some other videos with head pressure control valves and live streams and different things like that. If you go way back on my channel, or if you just search head pressure control valves, you'll see some stuff in there where I show some cutaways of different valves. So hopefully that answers your question about the fan cycle controls. I have systems out there that have fan cycle controls and head pressure control valves at the same time. So it really depends. Let's see what else we got. I'm sure I'm missing a bunch of stuff in here. Okay, so Randy Laz, what causes static charge coming off charging hose when charging a unit? I can tell you that that's because there's no ground and you're creating a static discharge because of how fast that refrigerant is running through that rubber hose, and it's creating a static discharge. I have seen that. I don't really have a solution to it. I imagine that if you ran a ground wire from the refrigerant tank to a ground source, then it wouldn't happen. But I realize that that's not very practical. But I've seen it on like at an old CPS scale that it actually shorted out the scale. I was watching it one time and I saw the spark go from the tank to the scale, and then the scale went blank and never worked again. So let's see what else. What am I missing? All right. Hey, Joe, thank you very much, man. I really appreciate that super chat. That was very nice of you. Thank you, thank you. Let's see what else. Yeah, Brad Taylor, it is fluid ounces, I believe, but, you know, I use the scale to weigh it. It's probably not correct. Again, I'm not expecting it to be the exact number. I'm just looking for a gross undercharge. So, yes, I believe that refrigerant oil is in fluid ounces. Let's see what else. And okay, so I've got a couple different topics I want to cover, and I want to go ahead and get to these, and then we'll start going through some more questions that you guys have, okay? So first off, I want to start out by sharing the PDF again one more time. So this is the Sporlan 90-30-1, and this is how I calculated that flooded charge, okay? So I definitely put a link inside there. That's how I calculate the flooded charge. It is really not that hard, guys. A lot of people said, oh my gosh, that was really interesting, all those calculations. Guys, this is just a little, this is like a 5-page book. All I did was read. I mean, actually, it's not even 5 pages. There's 2 pages of text. There's really nothing to this. This is the 90-30-1 bulletin. There's really nothing to this. There's 2 pages of text, and then there's 2.5 pages of numbers and charts to use where you get your density factor and your equivalent length for return bends. It's really not rocket science just reading these things and inputting the numbers. You follow their formula. It's a super easy calculation. And if you're so inclined, you put it into an Excel spreadsheet and boom, you just input some numbers. Really not that difficult to do, okay? So it's not rocket science doing that thing. Tom, you ask, how often do I change my filter on my Infocon DTEC Select? Probably not enough, Tom. I would say, in all honesty, I probably, if I notice that I feel like the leak detector is not working, I'll look at the filter and see if it's dirty. And if it is, then I'll change it. But, I mean, I don't know how often that is, 6 months, a year. It's not a regular thing. I probably should be changing it on a regular basis, but I don't. So, all right, let's see. HVAC Apprentice. HVACR videos. How's the... Oh, yeah, that's a different person. That was... You're probably thinking of... Ernesto, HVACR vlogger. He's the one with the new company. Where's the best place to buy 410A in California area? I don't know, man. I really don't shop refrigerant prices. I just go to my main supply houses and buy the refrigerant. So the supply houses that I typically will use are RSD, Allied Refrigeration, United Refrigeration are the three main supply houses that I use. And then every once in a while, I'll go to Train or Carrier or something like that, or Air Cold or something, you know, to get whatever particular brand. But for the most part, I shop at United, Allied, and RSD. All right, let's see what else. If I cut the headmaster tube at the top, what will happen to the valve fully open? HVAC Apprentice. So yes, if you cut the pigtail on a head pressure control valve, then the valve will not bypass anymore. But if the valve is stuck open, it might just be stuck open because there's sediment or some kind of contaminant stuck inside there, okay? So, but yes, if you clip the tip on the power head, the valve will not bypass anymore and it will go to normal refrigerant operation. Chad, thank you very much for that super chat. That was really nice of you. I really, really appreciate it, bud. Let's see. Who makes the best compressor HVAC kit? I don't know. It really depends on what I'm working on. Tecumseh or Copeland, they both, I think Copeland probably makes the better scroll compressor. They have all the technology. I do fine with just a normal reciprocating compressor. It could be Tecumseh or Copeland. Either one's fine with me. I mean, a compressor's a compressor. You know, I mean, they tend to pump the same. I don't know if there's really one that can take more abuse. I will say that the Man-Europe compressors and the Danfoss compressors and the Train 3D scrolls, they are pretty bulletproof when it comes to liquid refrigerant. But then again, so are the Copeland scrolls. So, yeah, I really don't have a preference. But if it's a scroll, Copeland probably. But other than that, Tecumseh, Copeland, I'm fine with them all. So let's see what else. Can I get anything less than 25 pounds of 410A? You only need about 4 pounds. No, you buy it in a 25-pound jug. I mean, you're not talking that much for a 25-pound jug, so a couple $100, not that much at all. Let's see what else. All right, so okay, another question that I have is, why did I go through all that trouble in my recent video to calculate the flooded charge? All right, I don't always do that calculation when I am charging a system. All right, I'm going to be honest with you guys. Oftentimes, once I've figured out the proper flooded charge, what I will do is I will pump the system down and I will mark the liquid level in the receiver with a paint marker. So then if I ever find a low charge issue again, I know where the liquid level is with the proper flooded charge. So that way I don't have to do the calculation every single time. Because there is instances, for instance, if you come out to a, yeah, you are right, Clint. Good job on the guess there, bud. Big Trouble in Little China is the movie quote. So if you, in the summertime, if you walk up to a refrigeration system that's low on charge, all right, well, how low is it? You don't, or actually no, in the summertime's not a good, but there's instances where you can walk up to a system and you don't know how low the charge is. And sometimes there's that weird instance, for some reason I can't think of it right now, but I thought of it earlier. There's that weird instance where you don't know how much refrigerant's been lost from the system, okay? And it's not feasible sometimes to recover the charge and weigh the whole charge in. So if you can calculate the flooded charge, you go through the trouble of it, then once you do that, mark the receiver level, and then from that point forward, you can fill it up to that receiver level because you know where the receiver level should be when it's pumped down. Okay, so that is one little quick method of doing that, okay? Let's see what else. What can cause flooding back at compressor? Suction line. What can cause flooding back at compressor suction line? And you're asking me if it's the TXV. Well, different things can cause flooding back to the compressor, right? When you think about the TXV, it's doing its job because it's trying to control the superheat, okay? Now, let's just say, for instance, you have low airflow or a dirty evaporator. I would expect to see low superheat at the compressor if you have low airflow or a dirty evaporator, okay? Because the expansion valve is still trying to feed the right amount of refrigerant through the system, but you just don't have the airflow for heat transfer. Therefore, your refrigerant's not boiling off in the evaporator. Therefore, you might get really low superheat or flooding back to the compressor. Other things that can cause flooding back, yes, is a failed expansion valve that's flooding too much refrigerant. It's an oversized expansion valve. All kinds of different things can cause it, all right? So I like to start out when I'm going to diagnose things is don't jump the gun. walk into the system or walk into the situation, evaluate everything. Does this look like a million people have worked on this equipment? And if that's the case, do you think it's possible they put some parts on there that aren't correct? In that situation, I'd probably start with a really quick load calculation. Call my supplier. If I can't do it myself, give them the box dimensions. Ask them how big the evaporator should be. Ask them what size expansion valve should be in the evaporator. You can also do all this stuff. You can just ask the Google, and it'll tell you all this stuff, right? Once you verified that the equipment's the right size, if you see that it has a new compressor in it, did they put the right compressor? Because I've seen situations where people put compressors that were too big or too small in systems when a condensed unit's a different size. Thank you very much, Zach. I really appreciate it. So it all depends on what I feel when I walk into the customer's location. In that situation, once I have evaluated the system and found out that all the components seem to be the correct ones, then I'm going to start checking things, okay? You're going to start checking superheat at the evaporator, and you may try to make an adjustment, but definitely want to make sure the system has the right charge before you do that, and go from there, okay? So hopefully that answers your question. If I don't answer you guys' questions, hvacrvideos@gmail.com. I'll be happy to answer them there too. As a tech, Storm Donald, thank you for the super chat, by the way. And you ask me, as a tech, how do you help customers move forward with repairs? Thanks. Okay, so it really depends, right? I put a lot of information in the customer's lap, but at the same time, I don't put too much information. And I know that's a hard thing to figure out, all right? I'm not going to go to the customer and say, hey, guess what? Your compression ratio is off. The amp draw is really low. The system's not performing. You got a bad compressor. I'm probably going to go to the customer and say, hey, you have a weak compressor. It's time to replace. All right. Too much information is going to confuse them. In certain situations, hey, your evaporator superheats way too low. I tried adjusting the valve. It's not working. You don't want to give them too much information, but you also don't want to go in there being very vague and not explaining to them what's going on. So you do have to find that happy medium of how to approach them with the problem. Thank you, Chad. I really appreciate that, bud. Again, wow, super chat's awesome, bud. Thank you so much. So, I just try to educate the customer, but there's a lot to it. It's not just going into the restaurant. I'm using restaurant because that's what I work in, but it's not just walking into the restaurant and telling them what's wrong. It's building a relationship with the customer, okay? The first thing, I don't care who you are, the first thing you do is you walk in and you shake the hand or bump fists with your point of contact, all right? The manager, the maintenance person, whatever. You say, hey, how you doing today? I'm here to work on this. You ask them, sometimes they're too busy for you, but you try, all right? How's this thing working? Has there been any history? Okay, it's just been my company. Okay, but do you know what we did? Okay, I'm going to make some phone calls. You kind of build a conversation and you kind of gain their trust, and then you walk through the equipment because you've built that trust. It's very important to make eye contact with the customer. But then, especially when you're talking to, I'm not trying to single anybody out, but especially when you're talking to female managers and female points of contact, you don't want to make them feel like they're small. Same thing goes with the gentleman too, either way, okay? But you want to go in and be on their level. You want to say hi, explain everything. This is what's going on. The system's not working because it has a bad expansion valve. But again, I never go in there and say, this is what's wrong. I always give myself a little buffer room and say, hey, you know what? The unit currently has a bad expansion valve, but we need to change that part before we can evaluate anything else. Always give yourself a cover your ass kind of thing. All right. That way you can, that way they understand like, hey, he came in and said, all he needs to do is change the expansion valve and everything will be good. But then it isn't good. All right. And I'm not trying to say to give yourself buffer so you can cheat them or anything like that, but you always want to give them that little bit of buffer room. So that way they understand that, hey, this unit has a refrigerant leak. I need to top off the charge first, or whatever they want you to do, then find the leak, and then we're going to evaluate the system from that point forward. I can't tell you if everything else is working fine. I can't tell you if the temp control is working fine, all that stuff, until I get the system charged and operating properly. Okay, so hopefully I didn't go off on too much of a tangent, and I kind of answered your question there, bud. Thank you very much, Juan Carlos. That was really nice of you, bud. Let's see. Yeah, customer relationship is a huge part of the job. All right. So, someone had asked me in the comments of the video that I released if you have to calculate the winter charge like I did if the system does not have a head pressure control valve, okay? No, you do not. If the unit does not have a head pressure control valve, you clear the sight glass or get it close to being clear till the box comes down to temp. Then you, clear the sight glass once it's closer to being down to temp, and you call it a day. You do not have to add extra refrigerant if the unit does not have a head pressure control valve, okay? All right. Do all train compressors have built-in accumulators? Nicholas Pope, that is a question I do not know the answer to, bud. I don't know about a built-in accumulator. I think by design, the way that the scroll compressor works, it can handle more liquid refrigerant, but I don't know about a built-in accumulator, so never heard that one before. What is going on? Yeah, okay, Joe. All right, let's see. All right, let's see what else we got. Okay, I'm going through my list of things. So Thomas, and this is kind of a change of subject here, but Thomas had asked me about discussing, he's in school, and he wanted me to discuss VFDs because I mentioned VFDs in my videos, and he just didn't understand what they were, okay? Actually, no, he's not in school. He's in residential, so he didn't understand the purpose of a VFD. So a VFD is an acronym for variable frequency drive. Variable frequency drive typically controls a motor, okay? And there's many purposes for having a variable frequency drive. Motor protection is one of them. They often have a lot of built-in motor protection. They have all kinds of safeties that can shut a motor off before a circuit breaker or anything like that would normally catch a problem, okay? But one of the biggest features about a variable frequency drive when it's controlling a motor or a pump is the ability to change the frequency, which is going to slow down and or speed up the motor. So for the most part in my videos, VFDs are used in package units, okay? Oftentimes we'll see them in a package unit. And what it's doing is on the package units, like a carrier package unit that I've shown VFDs in that have all kinds of problems, it's a Title 24 thing, okay? It's an energy standard that we have here in California that's quickly going all across the nation. But what essentially it is it's a two-stage blower motor, okay? So think about this. If we have a 10-ton package unit that has two 5-ton compressors in it, the typical rule of thumb, and this is a rule of thumb, again, you're going to change this number whenever you balance your building out and adjust your airflows, but the typical rule of thumb is that you're going to have 400 CFMs of airflow, right, per 400 CFMs of airflow per ton of refrigeration, okay? So if you have 10 tons of cooling, you're going to have 4,000 CFMs of air, right? Okay, so we have 4,000 CFMs of air, and we only have one compressor running in the air conditioning unit. We are now overshooting our airflow, theoretically, and we're not getting let's say the proper heat transfer in the evaporator coil. We're pushing air through the evaporator coil too fast, okay? Because there is times where you don't all necessarily call for both stages of cooling. So in that situation, to save energy, what they do is they install a VFD, variable frequency drive, to slow down the motor to a predetermined speed, so that way it can deliver, let's just say 2,000 CFMs of air when only one compressor is calling. And then when the second compressor comes on, it's going to stage up and deliver 4,000 CFMs, whatever it may be, whatever the designer has designed that AC to do, okay? So in that situation, that would be a purpose for having a VFD. Now, there's other instances where we have VFDs. We also put them on exhaust fans when we want more precise motor control, okay? We have super technologically advanced exhaust systems for restaurants. Maylink has a system called IntelliHood, and what happens is it has a bunch of VFDs, and there's all kinds of optic sensors and heat sensors, and whenever it gets really hot in the kitchen or there's smoke inside the hoods, then it speeds up the exhaust fans to a higher speed until all the smoke goes away, and then it slows down the exhaust fans to save energy. So there's all kinds of purposes that we might use a VFD for. So hopefully that answers your question for you, bud. There's tons of other purposes, but those are the instances where I use them the most. So let's see what else we got. What am I missing here? Okay, so Glenn, you're about to purchase a used dairy farm, but milk cooler, okay? Oh, bulk milk cooler. What would I recommend to prevent contamination of the refrigeration system? Well, if you're purchasing a milk cooler, all right, now it just depends. Is this a remote refrigeration system? I'm assuming so because it's a large milk cooler, so I'm assuming that the condensing unit is remote. So if that's the case, then a proper shutdown needs to be done. But I would say probably at a minimum that whenever you have the new equipment installed, you probably go ahead and change the oil in the compressor and make sure that whatever service company you use to install the equipment does a proper install. They change the dryers, and they probably should change the oil, because you never know what happened before you got it, okay, if that equipment is working properly. All right. There's definitely a lot more that you can do. I'd kind of need a little more context to your question. Feel free to send me an email to hvacrvideos@gmail.com, and I can probably help you out a little bit more. So let's see what else. Okay. HVAC Rookie asks, hold on. Okay, so HVAC Rookie, you said, if I find a system low on oil, how do I know how much oil to add? HVAC Rookie, that is the ultimate question. So the bigger the compressors, the more kind of oil control they have. They often will have sight glasses. They will often have oil level controls and different things like that. But when we're dealing with, just light commercial equipment, a 5-ton compressor for an air conditioner, they typically don't have any way of telling you how much oil's in that system. So the only way to really do a test would be to go ahead and pour the oil out of that compressor and compare it to the amount of oil that should be in the compressor. Now, if it has an oil sight glass, you can fill it to a proper level in the system. But here's the question. Where did the oil go? All right, that's the ultimate question. If you have a compressor that has not had any refrigerant leaks, but all of a sudden it's low on oil, that oil is likely still in the system. And if you just add oil to the compressor, the fear is that that oil will come back to the compressor and damage it, and or the new oil that you add to the system will disappear into the system too. Now, if you have refrigerant leaks, it's possible that the oil leaked out, but that's a lot of oil. So, that is a real question. I don't have very good experience with adding oil to compressors. For the most part, if a system has run in a compressor with low oil, the compressor, in my chances most of the time, is already damaged, and it's time to replace the compressor. But if you do proper preventative maintenance and you're regular on it, and you can catch a problem before it becomes a big issue, like you just start to notice the oil's a little bit low, but not really low, then you probably could save it by adding oil, but you need to figure out where the oil went, okay? And you need to figure out some sort of method to maintain that oil and make sure that it stays inside that compressor. There's all kinds of mechanical stuff you can add to systems. I really don't see them very much, but there's things like oil separators that take the discharge gas and they run it through a tank, basically, that captures the oil and brings it back to the compressor. So if it ever does leave, it won't ever leave the oil separator. There's all kinds of different things you can do. So, yeah. Let's see what else we got going on. Mr. Ice, do I rebuild or replace semi-hermetic compressors? Honestly, I don't come across semi-hermetic compressors very much anymore, Mr. Ice. I have rebuilt. Well, I shouldn't even say rebuilt. The most I've ever rebuilt on a compressor is just doing valve plates. I've never changed pistons or anything like that, because I work on smaller stuff, so it's not really economical for someone to spend all that money to rebuild a small little 1/2 horsepower, 3/4 horsepower semi-hermetic. It's easier for you to junk it and just put a new one in, get a core on it, and call it a day. But the bigger they go, the more cost effective it is to rebuild them. And I know on the supermarket level, they often will rebuild compressors if they are semi-hermetics. So let's see what else. Are 2 compressor circuits better than 1 tandem HVAC kit? I mean, that's a questionable thing. It depends, okay? So 2 compressor circuits, I mean, on a tandem system, you're going to have some kind of oil control. On 2 compressor circuits, you could just have 2 scroll compressors. I don't know. I don't know what the cost evaluation is on a parallel compressor system or a tandem versus just 2 separate circuits. I'd imagine you'd have to have some sort of capacity control if you have tandem compressors. So, yeah, I really don't know which one's going to be better, which one's a better situation. So, I mean, I could see upsides and downsides to both. Off the top of my head, one of the upsides is separate systems. That way you don't have contamination issues that affect both compressors. I mean, if you follow most manufacturers' recommendations, like on a train, IntelliPack unit or something like that. I mean, most people don't do this, but if you have a failure of a single compressor in a tandem situation, they often will tell you to change both compressors, especially if it's a burnout. I mean, I see people not do it, but I mean, in a situation where you'd have 2 separate circuits, there's no chance of contamination getting between those circuits. It's kind of hard to say. Let's see what else. Adam, you said your compressor is louder than normal, but you think lubrication or overheat can be the problem. It's always possible that lubrication is the problem. You can see overheat issues if it's louder than normal. You can thermal imaging cameras, but unfortunately, if you don't have a compressor to compare it to, and you've never used a thermal imager, you're not going to know what you're looking at. But if you look at a properly operating compressor, you can definitely see where the discharge or the head of the compressor is going to be really hot, but then, you know, the crankcase or the suction side of the compressor is going to be a lot cooler. And you can see temperature differences with a thermal camera. And then you can look at a bad compressor and you can say, oh my gosh, that whole compressor's red. There's something going on. More than likely going to be an oil return problem or something like that. So thermal imaging cameras can definitely be, you know, good use for people. Yeah, supply houses do pay you for used or old compressors. They want the cores basically. So really appreciate it, Ernesto. I thank you very much for showing the channel to other people, man. Any of you guys that are out here, you know, share the channel out. Let's help everybody. I just try to pass on information that I read or share. So if you guys know anybody that can use it, share away, show everybody that you can. Let's see what else we got going on. You wanted to ask ways I could determine whether a system is overcharged. You're talking refrigeration, Frank Bradley. Well, first off, you're definitely going to look at your vital signs of your system, okay? Look at your condensing temp. Look at your superheat. Let's look at your amp draw of the system. I mean, are you running a clear sight glass, but you've got really high head pressure? You've got really high subcooling? You know, those are things that can indicate an overcharge. You know, what you could do in a situation that you think is overcharged is go ahead and recover some of the refrigerant. It doesn't matter if you recover till it's, well, actually what you want to do is recover till it starts flashing. Recover the refrigerant till it starts flashing, then charge it in slowly from there, okay? You want to be cautious. When I say that you need to clear a sight glass, you also have to understand, you have to use common sense, because sometimes if it's an old system that was R12 and someone converted it to R22, then someone converted it to R404A, that system may not have enough volume for all the refrigerant that you need for it to work, available volume inside of it, you know, for all the refrigerant that it's needed to work properly, okay? Components may not be sized right. So you have to use some common sense when you're adding refrigerant to systems. If you think this thing's been Frankensteined and the receiver's not big enough, the condenser's not big enough, then certainly as you add refrigerant, it's going to start to be overcharged, and you know that it needs to have a clear sight glass, but there's not enough room in the system. That is something that happens, okay? That happens often too when people take, like, let's say for instance, a 3/4 horsepower Copeland condensing unit from the supply house, an indoor condensing unit, right? It doesn't have a doghouse, so you can install them on the roof, but people will put an enclosure over it. Well, if you guys look at the receiver and you look at your liquid line length, okay, let's just say your liquid line length is 50 feet, okay? The receiver on a 3/4 horsepower condensing unit that's an indoor unit is typically going to be like a 4-pound receiver. There's not enough room in that receiver to store all the needed refrigerant for that long line set length. So you have to be careful, okay? That's why oftentimes you guys will see in my videos, if I install an outdoor condensing unit or an indoor condensing unit, I'm oftentimes increasing the size of the receiver because I know from experience that that receiver is not big enough. You know, this line set's 75 feet long and it's running, you know, 4 coils, evaporator coils. I know that I need at least, you know, a 7, 8, 9, 10-pound receiver. So I'll install a bigger receiver. So keep that in mind. You do have to use common sense. It's not just cookie cutter, just go out there and install it and move on. So when I say clear a sight glass, I'm not saying that you need to go out there and clear every sight glass. You need to still look at them. You need to make sure that everything is sized correctly. You got to use some skills and some common sense to say, okay, that receiver doesn't look like it can hold enough refrigerant, you know, to do all this. So hopefully that I didn't go off on too much of a tangent and I kind of answered your question there, bud. All right. Any free online HVAC courses that are good? Yes, Adam Brecker, there is some good online HVAC courses. Now, free, maybe or maybe not. Depends on where you live. So there is a company out there. First off, HVACR School. My buddy Brian Orr produces a podcast. He does YouTube videos, and he sends out tech tips. So Google hvacrschool.com. Check out Brian's thing, throw in your email address. Trust me, he's not going to spam you guys. He's just going to send out his tech tips. He sends out a tech tip every day and lets you know when stuff's going on. Brian is a free resource for awesome training. Definitely check him out. Now, there's another training organization out there called HVACR EDU. All right. And they also operate under another name in Southern California called It's About Q. They oftentimes will have subsidized education, meaning free to you or a very small price, paid for by your utility companies, okay, or essentially paid for by us in the long run, but paid for by the utility companies, and they will give you all kinds of free training too. So they will, you just go to hvacredu.com or hvacredu on Google. Just look that up or look up It's About Q. See if they have any free resources in your area. Definitely check out HVACR School. My buddy Brian Orr, he's got great information on his website. So let's see what I'm missing here. Do I think VFDs cause motor winding damage or premature failure? Nicholas Pope. Well, there's certain things that you have to make sure happen when you have a VFD. So first off, you can have premature bearing failure on motors, okay? So they have to have what they call a grounding ring installed, a special kind of chingus that goes on the bear in front of the bearing basically, and make sure that you don't have any funky interference. And something about the VFD and some super technical stuff that's way above my head that causes bearing failures, okay? So that's one thing that can happen on a VFD. You can't just throw a VFD on any motor out there. You got to make sure that it's the right kind of motor. It's got to have these grounding rings on it to make sure that you don't have issues with the bearings. Now, do I think it's going to cause... I'm sure that there's some logic in the fact that you have to have an inverter duty motor, I would assume. All right. I'm not super technically smart when it comes to what type of motor can handle a VFD, but I do know that there's inverter duty motors. So I'd be cautious about throwing a VFD on any motor. Okay. So I'm sure there's some logic there. I definitely reach out to your motor manufacturers, and I'm sure they can help you out a little bit more and make sure that you get the right information to know what kind of motors you need to use. Maybe some people in the chat could help you out a little bit more. So, all right. Let's see what else. Do I prefer microchannel or copper fin condensing units for refrigeration applications? I prefer old school copper tube and fin condensers. I'm not a fan of the microchannel condensers. I understand the microchannel condensers are more efficient. Sure. Okay. I don't like the aluminum condenser. I really haven't had many troubles with them. I don't like change. Okay. Now, let me tell you something else. That Sporlan method 90-30-1 will not work on a microchannel condenser. Microchannel condensers, this Sporlan method to calculate the flooded charge 90-30-1 is only on a traditional tube and fin condenser. So a copper tube condenser with aluminum or with normal fins. It will not work on a microchannel. Microchannel has different calculations that you have to follow, and that's a really good stopping point and kind of transition into something else. So my experience with calculating the flooded charge for a microchannel condenser, I work with Heatcraft condensing units all the time. And they have their Hyperion core, I think, or Hyperion micro, whatever their condenser is called. It's whatever their funky name is for a microchannel condenser. But they have this weird calculation in the installation instructions, and I cannot make any sense of it. I've even called the manufacturer and said, dude, what does this stuff mean? And the tech support people, I've talked to multiple tech support people, and they basically tell you when you're charging a microchannel condenser, you just basically put the maximum amount of charge in the system. Now, I really don't buy that. I'm sure there's a way to calculate the flooded charge, but I haven't figured it out yet on the microchannels yet. Like I said, there's information in there, but it kind of contradicts itself when it shows you information on how to calculate it. So I just lean on each individual manufacturer of that equipment to figure out how to calculate the flooded charge. So keep that in mind, guys. Okay, what do you do when your compressor gets loud and locked up and overheated? Is it shot? Yeah, probably, Anthony D. If it's locked up, it's shot. It's time to replace. So do I use AC or DC motors for compressors and blower motors? So for the most part, we use AC motors, but in the residential side and even on some of the commercial stuff, they're going to ECM, electrically commutated motors. And those typically are DC motors that have a special control that converts the AC current to DC current, and then it's just a DC three-phase motor. So we do use DC motors in air conditioning and refrigeration, just not as common, I'd say, as just a standard AC motor. So let's see. Have I used another company for cleaning and protective coatings for condenser coils? Brett from Brisbane. Yeah, I've used off-site companies to come in and put special coatings like I can't think of the name, Luvata or Luvata, Luvata is a company that does it out here in Southern California. I really don't know much about them, but yeah, they do like some chemical coating covering that, you know, protects your condenser coils from salt corrosion and different things like that. And I do see benefit in it. I definitely see benefit for sure. So they also make coatings in a can. I don't know how well those work. I know that Refrigeration Technologies, which they make a lot of other great products, they have some coil coating that you put on evaporator coils and stuff like that for little reach-in coolers. So I don't know how effective. I've never used them, but I do know they offer them that you can just apply yourself. Do I ever add oil separators for long line sets or systems that have oil return issues? Sure, Robbie G. I've never done it myself, but it is something that we would do. I've quoted some oil separators for a couple different customers in the past. I never got them to approve them. And I don't do work for them anymore, but I have quoted them where we had horrible installations that weren't really correctable. So the easiest solution was going to be to add oil separators to all the compressors because we were constantly having to drain oil out of the evaporator coils. So in that situation, sure, I would quote to add oil separators for sure. But there's a whole science in sizing oil separators too, and I figured that one out. It's a whole thing. You got to make sure that you size them correctly. You know, there's a whole thing. So lean on the manufacturers for all of that. So. Oh, dang it, I saw a good question. So is it bad for a scroll compressor to short cycle on low pressure cutout due to a leak? Sure. Anytime a compressor short cycles is not good, okay? On, off, on, off, on, off. It causes the compressor to overheat, and the way that compressors are cooled for the most part when it comes to scroll compressors is suction gas coming back to the compressor. And the suction gas has to be cold. So when we have high temperatures in the box, then the compressor's not getting proper cooling. But if you have short cycling, the compressor's not running long enough for that suction gas to come back and cool the windings and internals of the compressor, so it can cause all kinds of issues. So you have overheat issues, and eventually it could cause premature failure, compressor to go bad. So yeah, short cycling is not good. Now, a low pressure controlled is there to protect that compressor though. So is it low on gas, or is there other issues too? There could also be improperly set low pressure controls that can cause short cycling, that can cause issues too. So, all right, I'm going to scroll down here. Have I worked on a system using R600 isobutane? No. Hoshizaki gave you a warranty call, but since the refrigerant isn't readily available, they decided to replace the entire unit. That was pretty smart. Jeff, I have not worked on any isobutane units, R600, but I mean, it's really not much different than R290. I work on propane R290 systems quite often. Just follow some proper refrigeration practices. I mean, even my videos on propane and R290, which you can just Google search R290 on my channel, or even just Google search R290 on YouTube and you'll come up on my videos. But it's the same process. It's just a flammable hydrocarbon refrigerant. It's no different using isobutane or R290. You can't interchange the refrigerants, but I'm just saying the processes that we follow are still the same. Just proper refrigeration practices, a couple extra added steps, purging with nitrogen before you braise, cutting as many components out of the system before you braise, that kind of stuff. So do some air conditioning systems have tanks that store refrigerant in case it runs low? I don't know that I've ever heard of a tank that stores refrigerant in case it runs low. I know that in some supermarket situations, they keep lots of extra refrigerant on hand for when they have refrigerant issues. But for the most part, we don't have stored refrigerants that I know of. I could be completely wrong, but anything that I've ever heard of, we typically don't have extra refrigerant for when we run out. For the most part, not that I've heard of. Have I worked on any AC systems that caught fire or previously caught on fire? I can't say that I've ever really worked on an AC system that caught fire. I mean, I've worked on reach-ins that have had terminal vents where all the components are melted, like there was fire blowing out the back of the compressor for like a very short period of time. But I've never worked on an AC system that actually caught fire per se. No, I have not. All right, I want to get to a couple more questions. Let me answer this one. Who makes the best refrigeration condensing unit? So that's a really good question, Isaiah. Who makes the best refrigeration condensing unit? That's kind of a hard one, actually. I prefer the Tecumseh pre-built condensing units, the outdoor condensing units that have reciprocating compressors. They were really nice heavy duty units that had all the needed accessories. The receivers were plenty sized correctly. Copeland condensing units are nice in that they have all that digital pressure control stuff, you know. Tecumseh condensing units are decent too. So, I mean, it really depends on what you're working on in certain situations. So I'd have to say probably, you know, like a little Tecumseh for like a true reach in. You know, it really depends on the certain situation. I don't have one that's better than the other. All right, so I'm going to get to my list of things. Okay, so Douglas had asked me about ice machine training, and he had asked me in an email about what books he could read to learn more about ice machines, what training classes he could go to. So this is a question I get quite often, and I'm going to tell you that there's not really a book out there that explains how ice machines work. But let me explain something first. Ice machines are basic refrigeration systems that just have funky controls on them, okay? Or they may have a funky evaporator or something, but it's a refrigeration system. Your compressor compresses the gas, okay? Creates high temperature, pressure, push through the system, goes into the condenser, changes state to a liquid, goes into the evaporator, absorbs heat, goes back to the compressor, okay? It's still a refrigeration system. They're just a little bit different because they don't typically use air for heat transfer for the evaporator. They use water, all right? They get the evaporator down below freezing, and then they freeze that water. What kind of training you can go through? What I would suggest, first off, is you need to understand the basic refrigeration cycle. If you don't understand the basic refrigeration cycle, you're not going to get very far on ice machines, okay? What I would highly suggest, this is not going to explain ice machines, but I tout this book all the time, Commercial Refrigeration for Air Conditioning Technicians. This is a book to learn refrigeration for technicians that already understand the basic refrigeration cycle, but it does elaborate a little bit and kind of explain the refrigeration cycle a little bit more. This book has like one chapter on ice machines. It just kind of gives you a basic idea of how an ice machine works. What you want to do, though, is you want to lean on the manufacturers of each particular ice machine. There's no magic involved. Hoshizaki Ice, the main players in restaurants. Hoshizaki ice machines, Manitowoc ice machines, Scotsman ice machines, Isomatic ice machines, Follett ice machines. Those are the main big-time players in restaurants, okay? There's a couple other little ones too, but those are the big boys. And out of those ones, I would say Manitowoc, Hoshizaki, and Isomatic in my area are the more popular, okay? Each one of those ice machine manufacturers has a website, and they have all kinds of training resources on their website. They also have free training or somewhat free training that they will offer once a year. Ice machine training season is coming. It's typically at the end of wintertime, usually between January and April. Most of the ice machine manufacturers are doing their training classes. All you got to do is reach out to the ice machine manufacturers, and they usually go across the country and do all kinds of training, okay? So that's probably your best bet to learn about ice machines. First off, understand the basic refrigeration cycle. Then get a hold of the ice machine manufacturers, download the manuals, read the information. Each ice machine uses the same principles, but they all use a different method of defrost or how they may form their cubes, how they harvest the cubes, different things like that, okay? So hopefully that answers your question for you there, bud. The next question that I had on my list was why I used a defrost on my walk-in cooler that I just recently made the video on during the day. Someone had asked me, why the heck do you have a defrost during the day? Why not just use off-cycle defrost? Why do I even have a defrost clock on the walk-in? All right, when you're dealing with restaurants, it is a must on a walk-in cooler that we have some sort of timed defrost. Off-cycle defrost is not very effective when you're dealing with restaurants. Off-cycle defrost is basically whenever the thermostat turns the box off, it brings the box temp up to a certain temperature above freezing, then it turns back on. The reason why we need defrost on a walk-in cooler is because of our evaporator TD and the heat transfer principles. If we're trying to maintain 35 degrees in our walk-in cooler, then typically our evaporator is going to be somewhere around 25 degrees. So the evaporator temperature is going to be 25 degrees. So that means that you can start to have condensation particles that start to freeze on your evaporator, and slowly over time they build up. Now, in a perfect world, the walk-in door stays shut, the off-cycle defrost will take care of it. But in restaurants, 99% of the restaurants out there use their walk-in cooler as a reach-in cooler, and they're in and out of it every 2 seconds. Open, close, open, close, open, close. There's all kinds of heat infiltrating into that box, creating condensation on the coil, and it starts to build up ice, and you get freeze-up situations. So I'd say that it's pretty safe to say that 95% of the walk-in coolers out there need a time defrost throughout the day to make sure that we have no ice formation on the evaporator coil, okay? So what we typically do is add a defrost strategy to the system, all right? And, you know, they have newer walk-in cooler and walk-in freezer evaporators that sense the evaporator temperatures and decide for you. They have a computer inside of them. They decide for you whether or not they need defrost. It's kind of a demand defrost. But on the older systems, old school, which is kind of where I come from, we have just a defrost timer on there. We throw 4 defrosts a day for 20 minutes and call it a day. Maybe an extra one for 45 minutes in the middle of the night or something like that, okay? Now, on a walk-in freezer, there's no questions about it, ifs, ands, or buts. You need defrost, okay? Hopefully that answers your question for you, bud. I'm just looking through my questions that I had on here. I definitely discussed that. Okay, cool. I kind of went through that. So definitely throw some more questions. Okay, so Dark Sabata asked me if there's any books best for rack refrigeration systems. Rack refrigeration is going to be a pretty complex subject. You definitely are going to get a little bit of it in commercial refrigeration for air conditioning technicians. All right, there's going to be some rack refrigeration equipment. More or less, it's going to explain the controls and different things. I would highly suggest that you lean on the manufacturers. Every refrigeration manual out there, fundamentals of HVACR, there's a whole bunch of different refrigeration manuals. They're all going to have some sort of principles that talk about rack refrigeration. A lot of times the best thing in rack refrigeration is you just need to get out there in the field. I don't do rack refrigeration, nor have I ever worked on supermarket stuff. I understand the concepts of it, but I'd probably be in a world of trouble if I even walked into a equipment room. So, all right, let's see what else. Have I seen, let me see. 3 to 11 p.m. and a pay cut. That's a bummer, Jeffy. All right. Why does the Train rebrand their compressors? Well, Train will oftentimes have, actually for the Reliatel compressor, what do they call theirs? Train has Copeland make some of their compressors. The smaller scroll compressors, they have them made by Copeland. I know that. And then the bigger compressors, the 3D scrolls, I believe they have them made by Danfoss, if I remember right. So, I mean, why I think Train just likes to make everybody think that they have to use their compressors, when oftentimes their compressor might be a little bit different. But I mean, I've seen plenty of times where people will take just a Copeland compressor and throw it into a Train, or a Danfoss or MANUREP compressor and throw it into a Train too, and it'll work just fine. So, but you know, I'm an OEM fan. I like to put the OEM parts back in, but it's just a marketing thing in my opinion. So I'm sure there's someone out there that's going to say there's something different or something like that. But I know that Train will definitely do some weird things with the BTUs and stuff like that, so it makes it harder to cross-reference compressors for sure. So, have I seen systems with 2 liquid receiver tanks? No, Sean, I can't say that I've ever seen a system with 2 liquid line receivers. I'm not going to say it doesn't exist, but I don't know that I've ever seen that before. So, all right, let's see what else. Constant cut-in replaced in a true cooler with aftermarket Ronco. Warmest setting and box still reaching 32 degrees. Moved element 3 times in the coil. So, okay, constant cut-in temperature controllers are often misdiagnosed. And, you know, if there's any kind of refrigeration problem inside the system, restriction in the capillary tube or an expansion valve not feeding correctly, constant cut-in controls will make people think that they're the problem, but they're not actually the problem. I'm not saying that's your issue, but you need to make sure that you have proper refrigerant pressures when it's running. Talk to the manufacturer of the True box, okay? On a True 134A cooler, you know, I can throw out some rules of thumb, but typically you're going to see anywhere from 8 to 13 suction pressure when it's down to like 35 degrees, and you're typically going to see no more than 150 head pressure on a 134A cooler. Now, R290, 404, totally different. But that was one of the most common gases we used on 134A with True coolers. So that 150 head pressure, that's assuming that your ambient temperature in the building is not over 80 degrees, because they won't operate properly over 80 degrees, okay? So if you have any kind of restriction or refrigerant problem, then it's going to make you think the temperature controller is the problem when in actuality it's not. Because if you think about the concept of a constant cut-in temperature controller, the sensing element is embedded in the evaporator coil. So the evaporator coil's heat transfer has to be working properly. And if the charge is low or overcharged, then that coil might get warmer or colder in the spot where you have the sensing bulb. So it can fake you out, making you think that you have an issue with the control. So before diagnosing constant cut-in controls, you definitely want to check the refrigerant pressures. If it has an expansion valve, check the superheat, talk to the manufacturer, and then replace the control. Now, I highly recommend installing the factory OEM constant cut-in controls and not the aftermarket ones, just because I'm a fan of using the OEM parts. I realize there's a lot of people out there that use non-OEM parts and they work just fine, but it's just my preference. It's easier for me because the OEM part works. Call it a day. So would I like to work on market refrigeration? I actually would love, Carlos, to learn market refrigeration. It's just unfortunately not something that I can do. I run a small business and it's not something that I could transition into. But yeah, sure, I would love to learn market refrigeration. That would be a really cool thing to do. But in no way do I want to work the market refrigeration hours. No. I like my once or twice a month overtime service call at 2 a.m. I don't want to be doing those service calls every single day. I think that's nuts. Not going to happen for me. So, hey Ted, how you doing, bud? All right, let's see what else we got. Let's see. Can thermal camera show liquid receiver level without torching the receiver? David Johnson. Now, I have tried that experiment. I bought a thermal imaging camera. I did not buy a very expensive one. I bought the FLIR 1 Pro, and I tried looking at the liquid receiver level in the receiver, and I could not see it. But after I heated up the receiver, yes, I could see the liquid level with the thermal camera, but that kind of defeated my purpose of having the thermal camera. My concept of having the thermal camera was being able to potentially pump it down and not even have to heat up the receiver and just look at it and say, boom, I could see the liquid level. But no, for me, it did not work. I could not see the liquid level. But again, once I heated it up, sure, but what's the difference? I'm not going to have a $500 thermal camera that I could just use my fingers to feel the liquid level. So, what is the biggest refrigeration leak I've encountered? I've probably brazed shut a hole much bigger than I should have in a temporary situation. Maybe a hole that was a 1/4 inch in diameter, and you just slowly bridge it, starting from one side, laying solder across, and building it up, and then eventually plug the whole hole. That's about the biggest I've probably ever done, was like a 1/4 inch hole. Probably didn't look good on the inside of that pipe. I could only imagine what that solder was doing inside there, but I don't know if that's the question you had for me. So where can you find how a ventilation system works? Adam Brecker. I have some videos on how ventilation systems work, Adam. What kind of questions do you have? Throw them in there. For an exhaust fan, give me some context. What do you want to know? I'll talk about it, man. So I can give you a general idea, okay? And I'm going to cover this real quick. Air balance. Air balance is one of the easiest things. Well, not easiest, but it's a pretty easy concept to understand. We use exhaust fans in a kitchen to pull unwanted air out of the kitchen, and you can use them in medical settings and all kinds of stuff. But kitchens are the easiest because they're kind of complex, but there's a lot of things that go into play. So we use an exhaust fan to pull unwanted, hot, smoky air out of the building. We got to put air back into the building to make up for what that exhaust fan is pulling out, okay? Use a paper bag, put a paper bag over your mouth and suck, and the bag's going to collapse. But if you cut a hole big enough in the bottom of that bag, when you suck on the bag with it around your mouth, it's just going to pass right through. That concept, when we pull the air out of the building with the exhaust fan, we got to add makeup air back into the building. So we have a makeup air unit that's sized properly, and that balances out the building. That's just a general of how ventilation systems work, but I'm sure if you got more questions, either throw them in the chat or send me an email to hvacrvideos@gmail.com, and I can give you some more answers. Whatever I have, I'll give you what I got. So let's see what else I got going on. How do I set a fan cycling switch? Jose Fernandez. Okay, you got to find out what your happy number is for liquid or condensing temp in your condenser, and that's going to tell you where to set your fan cycle switch. Typically, most fan cycle switches for 404A refrigerant, for R22 refrigerant, they're going to be set around, cut out at about 200 PSI, cut in at about 250, so that way you can maintain about 100 to 105 degree condensing temp, no lower. You may see some numbers change depending on some funky equipment, but most fan cycle switches for 404 and 22 were set around 200 cut out, 250 cut in, somewhere in there. But, you know, if it has multiple fan cycle switches, they may stage them, different things like that. So let's see. Have you ever used R427A to replace R22 on a walk-in cooler? Justin, yes, I have. Not on a permanent situation, but on a temporary solution. So what happened was I had a condensing unit go out on a walk-in, or let's just say a reach-in cooler. Okay. So I have a video on it too, but I had a condensing unit go out. And at that time, the customer was not able to upgrade the system because the evaporator was in really bad shape, and I wasn't going to change just the expansion valve in the evaporator. Okay. So I knew that I was going to be going to 404A refrigerant eventually. So what I did in that situation, we had R22 existing, was I went ahead and put in a new condensing unit, knowing that eventually I was going to change it over. And I put 427A in there temporarily. This new condensing unit had polyester oil, which is the perfect oil for 427A, okay? And I used that in the interim until a couple months later when the customer was ready and we changed the evaporators over, and then I went ahead and put 404A in the system, okay? Now, 427A, I'm not a fan of using any of the refrigerants that they say you can use with mineral oil. If you read the technical documentation for 427A, it says it works best with polyester oil, but it will work with mineral oil. I've had bad luck with 427A with mineral oil. So my preference is if I'm going to use any of those alternative refrigerants, I'm going to use it with polyester oil. So either they're going to change the oil in the compressor or change the whole compressor, which I'm not a fan of putting polyester oil in an old ass compressor that had mineral oil in it. I'm not going to do that. So just change the condensing unit and move on. So hopefully I answered that. Ask me some more questions if you got them. Off topic. When are my wife and I doing another video? So that's a question. We were just talking about that today. It's just a matter of us doing it. We just honestly haven't had a lot of motivation to do another video, but we definitely have some other things we want to talk about. We'll get to it. It's just one of those things where it's also been hard too because she's a waitress and she works. So our schedules kind of conflict. So, but we'll definitely do another one soon. What else? What's my definition of superheat and subcooling? Carlos Cervantes. That's one of those questions that everybody keeps asking me, but I want to come up with like the right answer and definition of superheat and subcooling. And I don't want to confuse you guys. I'm a person that likes to come out with these super technical answers, and I really need to do it. I'm just not prepared to come up with a definition of those. Okay. So, I mean, I understand how they work, but it's explaining things that gets kind of difficult for me when it comes to certain things. And I want to make sure I get all the terms correctly when I'm explaining to you guys. So I'll definitely cover that soon. So, let's see what else. Got that. What's my opinion on the quick response controllers on walk-in evaporators with the EEV? So, Soul Survivor 1, I have several of the QRC coils out there. I've installed probably 10, 15 of them. Really haven't had many problems other than temperature sensors that have failed on them. Not really much that I could say. Just follow proper refrigeration practices. Make sure that the controllers are set up right. Now, I will say, if you're buying a QRC evaporator and you're buying a Heatcraft condenser, one of the biggest pieces of advice I can give you, on the new Heatcraft condensers, they send them with a time delay relay. Okay, so that way the pressure control doesn't short cycle. Take that time delay relay and throw it in the trash when you have a QRC evaporator. You will have nothing but problems with that time delay relay and that control board down in the QRC evaporator. So from experience, even from tech support telling me, do not let those time delays stay in the condensing unit if you have a QRC evaporator. Now, if it's a beacon system, it can probably handle the time delay if it was built into the system. But the QRC is kind of a dumbed down beacon system without all the funky controls and different things. And the QRC just has an EEV and a couple evaporator sensors is all it is. So hopefully that helps you a little bit there. Adam, how does an expansion valve work? Well, that one again is one of those really technical things that I understand how it works. This is an expansion valve right here. You're going to have, and again, I'm not going to go crazy into this, okay? But an expansion valve essentially takes liquid refrigerant and meters it through a very small orifice and flashes the gas off to a saturated vapor. And that vapor, or a vapor basically coming out of the expansion valve, and that vapor runs to the evaporator coil, and then helps to absorb the heat of the air passing over the evaporator coil. So the expansion valve changes the state of your refrigerant from a liquid to a vapor, so that way your evaporator can work properly, okay? Now, as far as what are the closing forces and opening forces, I'm not going to go crazy into that right now because I'm not going to bore everybody to death. Maybe I can make a video on those. You can open up any of the refrigeration books, and it really goes into detail about that stuff. I really don't get too nerdy with the expansion valves, okay? They're pretty simple devices, and that if it's not maintaining superheater, if it's not letting refrigerant flow, a lot of times the power head has failed. Change the power head. There's not a lot of functions in the valve that can go bad for the most part. So send me an email if you want some more answers to that question, hvacrvideos@gmail.com. Evaporator heaters going red, amps and voltage are okay. If your evaporator heaters are going red, that sounds like they're overheating. Usually they don't get hot enough to turn red. I mean, I don't know how long they're running for. In essence, I mean, the longer they run, the hotter they're going to get. Yeah, that's true. But for the most part, your evaporator heaters typically won't run more than 20 minutes or so. I mean, they shouldn't be getting hot or red hot like that. That means something's going on there probably. Okay, so Justin P., you have liquid injection that need to adjust it to get it to stay off when pumped down, so it won't short cycle and overheat anymore. So Justin P., okay, first off, liquid injection, is it a DTC valve? Okay, if it's a DTC valve, that's a defrost temperature controlled valve, or discharge temperature controlled valve. So it has a sensing bulb in the head of the compressor. Typically on the DTC valves, you don't have to install any kind of shutoff to them because they open and close. Now, if you have a heatcraft condensing unit that has a liquid injection valve, because that is on the heatcraft condensing units, they're supposed to have a liquid line solenoid valve in front of the liquid injection valve. And even in Copeland's installation instructions, it says you don't need a liquid line solenoid valve on the DTC valves, but you can install them if you're having problems. So on a liquid injection, you definitely need a liquid line solenoid valve before the liquid injection to make sure that you're not having issues on pump down. So you definitely have to have that some sort of shut off there. On the heatcraft condensing units, they do it by having a liquid line solenoid valve that's controlled by a current sensing relay. Whenever the current sensing relay senses that the compressor's running, it grabs one leg and runs it through the current sensing control. It opens the solenoid valve for the liquid injection, and whenever the current goes away from the compressor leg, it shuts the solenoid valve for the liquid injection. That way the system can stay pumped down essentially. Okay, got you. Do ECM motors? Sorry, I didn't know if I was getting caught up in stuff. Sorry about that, Justin. If you already knew that answer. Do ECM motors, Mr. Ice, take AC voltage and convert it to DC to be able to regulate speed? Yes. ECM is electrically commutated motor. That is actually an ECM motor is actually a DC 3-phase motor. Okay, so it takes AC current, it converts it inside the motor board, whatever that fancy board is inside there, changes it to DC, and then regulates the speed of the motor via DC voltage. So yes, a ECM motor is actually a DC motor, but it takes AC power to control it, and then it just changes inside the motor. I think it uses like rectifiers or some funky stuff to change the voltage or something like that. Sorry, hopefully I didn't stomp on your toes there, Justin P. Carlos Cervantes, EPR valves, evaporator pressure regulators. Honestly, don't use them a whole lot. I'm not really going to go into context on that because that's more of a supermarket thing. I really don't use evaporator pressure regulators too much. I kind of have a general idea of how they work, but not enough to go and explain them to you guys. Do exhaust fans use AC or DC motors? For the most part, exhaust fans use AC alternating current motors. Oftentimes, they will be 115 volt motors. They can be 208 single phase motors. They can be 208 three phase. They can be 460 volt motors, 3-phase. They can be any voltage out there. But for the most part, they are AC motors. Sometimes they will have variable frequencies, VFDs on them, variable frequency drives. Sometimes they won't. It just depends. Sometimes they'll be direct drives. Sometimes they'll have belts. It really depends on the situation. So hopefully I answered that one. Any podcast updates? Sacmandu. Honestly, it's just something I really haven't dove into, a podcast thing. I've thought about it a lot. I even like started the process, came up with a name, but it's really something I haven't jumped into and committed to. Like I said, I was going to do it, and then I just really don't have a lot to talk about. I don't know. I just really don't have confidence that I have a lot to talk about on a podcast. I've definitely been a guest on a lot of podcasts. Maybe I need a co-host or something. I don't know. Okay. Compensation. Contest over. You shared a pic after I said they need more people entering, but don't know if they seen it. So hashtag Sporlin85. Compensation. Share that pic again. My contact at Sporlin has said that almost, I can't guarantee you that everybody's going to win, but almost everybody that is entered the Sporlin contest is getting a really good chance to win. So share that pic again, bud. So what you want to do for the Sporlin 85 contest is share the hashtag Sporlin85. So # Sporlin85. My daughter said, #, you're showing your age, Dad. Well, I don't see it as a hashtag. I see it as a # because I remember phones where you had a #. So # Sporlin85 and share any picture of any Sporlin product, whether it be old memorabilia, new memorabilia. Heck, take a picture of an expansion valve. Share it on Facebook with the hashtag Sporlin85. Facebook or Twitter, you can share them, and you will be entered into the contest. If you want to, you can tag Parker Sporlin. You can tag myself. I'm not a representative of Parker Sporlin, but I mean, if you're having a problem getting them to recognize your thing, then tag me, and I'll try to make sure that they get it to them. The contest is to get a free the beer mugs. Hold on. So they have these commemorative Sporlin glasses that I usually have my apple juice in, Sporlin 85. So yeah, the contest is going to go on for a couple. I think it might go on till the end of the year. It's going to go on for at least the rest of November. I think all the way till the end of December. I think, but don't quote me on that. And they're giving away more of these mugs. So anybody's eligible to enter. Just go on to Facebook or Twitter and tag Sporlin with the hashtag Sporlin85. Yeah, there definitely is not a lot of good. Oh, cool. Right on, Fluke 196. So there's definitely not a lot of supermarket rack technicians making YouTube videos. There's about three, I think, that I know of, maybe 2. So Rookie Refrigeration, that's Ruben. He makes them. And then there's a guy here local in Southern California that makes them. I can't remember his YouTube channel name. And then I think there's one more, too, that makes rack refrigeration videos. So do I put pineapple on my pizza? Hell yes, I put pineapple on my pizza. So, all right, is direct drive better than belts? I prefer a belt-driven fan, okay? But belt-driven fans have more things that wear out. You have to change belts. The reason why people have gone to direct drive, in my opinion, is to save money, but it creates more of a hassle for us service technicians because it makes it harder to find a motor. When you had a belt-driven motor, they were a lot easier to pick up at a local wholesaler. When you have funky direct drive motors that have weird brackets and crap like that, you tend to have to go through the manufacturer to get the motor, so you run into problems when you go to change them. So yes, on a belt-driven motor, you have pulleys or sheaves that go out. You have belts that go out. So there's wear and tear and maintenance that needs to happen. On a direct-driven motor, there's not a lot of maintenance. You need to make sure electrical connections are tight. You need to make sure motor vents are clean. But other than that, there's really not much more you need to do to a direct-driven motor. But from a service technician standpoint, I like the belt-driven motors because they're easier to replace when they go bad. So, all right, what else? Okay. You making fun of me because you don't like pineapple on your pizza, Joe? All right. All right, let's see. Thomas, discuss what an apprentice... Okay, sorry. Oh, okay, this is another thing. Question that I had. Don't have your name here, but someone had asked me as an apprentice what they can do to stand out in the trade. Okay, this is a great question. First off, as an apprentice, what you can do to stand out from the next guy, okay, is be interested in the trade. Put yourself out there. Ask questions. But at the same time, do not ask questions at the wrong time, and don't be an ass. All right? Don't be asking questions that make people look stupid. Even if you know someone is not doing something correct, be cool about it. Ask questions, do research, provide information, and talk to them. Okay? Don't be a dick. Don't be rude. All right, that's one thing, is ask lots of questions. Anytime you're out in the field as an apprentice, take pictures when you're allowed to of equipment, model numbers, and serial numbers. When you go home, research that information, download it, print it out, put it on your phone, and read about it, okay? go to any training you can get, whether it be provided through your company, wholesale houses, look up the local wholesale houses, any training you can get to. Be the first person to volunteer when they need help, all right? Always be available and just put yourself out there and be willing to learn, okay? Absorb what you're going to get out there because there's going to be a lot of information coming. You're not going to learn it all in one day, but absorb as much as you can and ask lots of questions. But remember to ask those questions at the right time, okay? When you're applying for jobs, show the potential employer that you are willing to learn, all right? Explain to them why you want to work in this trade. Tell them, hey, this is what I want to learn. This is what I've done. Show people that you're interested, okay? Put yourself out there even before you get a job as an apprentice or before you go to school, before you go work for a company, okay? Start enrolling in taking free trade classes at supply houses, researching online. Just because you see some guy on YouTube making videos doesn't mean he's right. So do the research yourself too. Don't just take something that I say as to be the golden rule. If you hear something that sounds interesting, then research it. Read a book. See if what I say is the same. See if it sounds the same. There's lots of people out there making videos that are horrible. Maybe I'm one of them. I don't know. You guys got to vet the information and don't just trust because you heard it on a video. The next thing, there's a lot of old timers in the industry that you can learn a lot of information from that don't always necessarily follow all the proper refrigeration practices. I'm probably one of them. I don't necessarily do everything correct, okay? Even if you know something is wrong, again, I can't stress enough, don't be a dick about it, okay? Just, you can ask questions. Hey, this doesn't make sense. When I was in school, they said to do it this way, but you're doing it that way. Ask them in a nice way, and maybe they'll explain to you, yeah, the other way just doesn't work, and this is why. Just because you see someone that's doing this and you know they're doing something wrong, maybe there's a reason they're doing it that way. Not saying it's right or wrong, but just be humble and be willing to learn, and that's what makes you step out or stand out as an apprentice. Because I have to say, there's a lot of young blood coming into this trade right now that don't want to work, that don't have drive, and that don't put themselves out there. They just want it to be handed to them. So if you're that technician that shows that you want it, you're going to get it. Okay, so hopefully that answers your question for you, bud. All right. Let me see. All right. Have I had any troubles with pull downs achieving holding the target micron level with non-vacuum rated VCRTs? Dude, I have had so many troubles, and I'm going to make it first and foremost out there right now. I got these fancy vacuum hoses. I got these fancy micron gauges. I got fancy vacuum pump, all this different stuff. Just because you have all that stuff doesn't mean that the system's going to pull down to a proper vacuum. When you're dealing with old equipment, a lot of times it has leaks. A lot of times it's not possible to fix all the leaks. So a lot of times you have to work with what you got. I do my best to pull proper evacuations. I know I'm not quite answering your question, but I will. I do my best to use the proper materials, but sometimes systems just don't pull proper vacuums, okay? You do your best with what you have. You pull down to what you can. You do what's practical, all right? Now, vacuum rated versus non-vacuum rated VCRTs. Honestly, I've only ever used vacuum rated VCRTs. That's a vacuum core removal tool. I've used the Appion vacuum core removal tools for many years. And then recently I got the Yellow Jacket vacuum core removal tools that were specially made for the True Blue hoses. Okay. Both of them, they work great. All right. But it's my system that's oftentimes the problem. Now, sometimes too, it's your hose setup or the way that you have the hose tightened down and you're over tightening hoses on the connections, and that can cause leaks too. Okay. So don't assume that you're always going to have a perfect vacuum, especially if you have old equipment. You're never going to achieve a proper vacuum if you have a pumped down system because you're pulling against components in the system that will leak. All right. But always do your best to do everything that you can, but you're not always going to achieve that perfect vacuum. Okay. On new installations, you're going to get pretty close to a perfect vacuum. But on retrofit and repairs, a lot of times you're not going to obtain that perfect vacuum, okay? Hopefully I didn't just throw myself out there, but I mean, it's the truth. So, all right. How hot do motors get on exhaust fans, Adam? They typically don't get that hot. I mean, they usually have cooling. So I'd say 120, 130 degrees. Maybe I don't think you're going to be getting over 200 200 degrees on a motor. Usually they have cooling built into the fans. Just trying to get on. Yeah, definitely, bud. All right. Why would a walk-in freezer system need a headmaster and fan cycling? Well, because oftentimes the manufacturers of that equipment will put a fan cycle and a head pressure control valve because that equipment was made to work in a broad spectrum of climates. So we have an equipment manufacturer here in Southern California, let's just say, that produces equipment for Southern California, where typically we honestly don't need head pressure control valves, okay, or headmasters, but they do serve a benefit here, okay? But they also are going to ship that to Minnesota, where they're going to see way negative, or up to Canada, where they're going to see ridiculously low negative temperatures. Maybe not to Canada because you guys got weird import laws, but you know what I'm saying. I mean, they want to be able to ship that equipment to multiple climate zones, okay? So therefore, they're going to make it basically operate down to negative 20 degrees. So they're going to add fan cycling and head pressure control to it. So that's why you'll typically see that. Now, a manufacturer that does that was Cold Zone, or Russell at the time. Okay, Cold Zone used to make all their equipment operate properly down to like negative 20, so they would have fan cycle controls and head pressure control valves built into them, and then they'd have like funky delay relays, that you know, all kinds of weird stuff, low ambient controls basically. So, all right, let's see. If I'm missing questions, guys, we're getting towards the tail end of this. Throw them in here again, okay? Radial or axial fan, which is best for an evaporator? Honestly, I don't really care either one. They both, if you have a proper fan blade or blower wheel or an axial fan, I'm good with either one. It really, as long as it's moving airflow, I really don't care much. You know, it all depends on what kind of equipment they're putting it in, the size of the stuff. So I really don't have much of a preference. Have I ever had to deal with a pest or what is the worst experience? I've had all kinds of weird stuff. No worries, Adam, bud. You guys can ask any questions you guys want. You're not affecting me here, okay? So what is the weirdest pest that I've ever seen? I've had package unit in a restaurant that we have high winds out here. Typically, we have what we call the Santa Ana winds. We just had a wind event recently where we get like 70-mile-an-hour wind gusts. And what they'll do, they'll go to a restaurant and the winds will rip panels off of ACs, or if people don't put enough screws in them, they'll rip the screws out of the panels. And so I had a restaurant where some of the panels blew away and we didn't know where they were. They literally blew off the building. And so before we took over the restaurant, they had several panels missing. They had outside air filters missing. And so birds actually flew into the return air ductwork and nested inside the ductwork 8 foot down. And they actually hatched baby birds down inside the ductwork. And so they were having smells and all kinds of, it was pigeons. So they were nasty, like flying rats. And yeah, they were stuck in the ductwork and we had to fish them all out with, like, we had to like go to the sporting goods stores and get nets and like fish all the birds out of the ductwork and throw them out. So that was an interesting one. But other than that, we really don't have too many pests out here in California. In my areas, I know that a lot of the residential guys got to deal with squirrels and different things like that, raccoons getting into the blower assemblies and stuff, but I don't have to deal with that too much. So, all right. How do I change the rotation of a single phase PSC motor that doesn't have the reversing wires on the back of it? It's not meant to be reversed if it doesn't have reversing wires. So single phase motors, typically the direction of the motor is the direction that it goes. So either someone installed the wrong motor or something's failing in the motor that's making it go backwards. So, right on. Thank you, Joe. I really appreciate it. What has been my most challenging service call? My most challenging service call. Carlos, that is a really interesting one. Yeah, I don't know if I could really think of that one right now. I'm going to write that one down because that's a question that I've been asked many times. So what was my most challenging service call? And I'll try to think of that one and then answer that one and in a future stream. What challenging call? Okay, so I'll try to answer that one because I don't know off the top of my head what my most challenging service call is. So, all right. Really appreciate it. All right. Am I trying to get an inrush current? All right. We are going to. I am going to wrap this one up. Guys, if I missed any questions, I can smell dinner being cooked in the other room. So it's time for me to call this one a quits. If I missed any questions, feel free to send me an email to hvacrvideos@gmail.com. I will also try to go over this chat and see the after the fact and read the log and see what questions I missed and definitely try to address them. Don't hesitate to send me an email. I really appreciate you guys coming in here to watch this stream. Any other questions, like I said, emails, text message, you know, all the normal platforms, send me a message and I'll try to get back with you on that one. Okay. I'm going to go ahead and cue up the outro music. And again, I really appreciate you guys coming in here, and we will catch you guys on the next one. Okay.